Hi, and welcome back to C Programming Skills using Replilt. I'm Norman McIntyre. Let's get started. Here we're going to talk about time. Time is kind of important, and we'll get an introduction to some of the functions that deal with time. So we'll begin with our Hello World project, and I'm going to include a new header file, time.h. So again, I want to stress as a software developer, the more header files you're familiar with, and the more functions you're familiar with inside those header files, then the better you will be, the more productive you'll be. So let's begin with one. Probably the best place to begin is one called time. And notice this looks a little different from what we've seen before, because so far we've been dealing with integers and character pointers. But here we see something called a time_t pointer. Now remember, anytime you see a star, say pointer. So a time_t pointer called timer. Now I realize that's a little unclear right now in this course, but it turns out we can ignore that by putting null. Now null, and notice that's all capitals, it says do not send in a pointer. Make it null, which is basically 0. Don't send in anything. Don't send in a pointer. Think of your pointer as like your finger, right? Your index finger. You're pointing to something. Here we're saying don't point. Just make it null. Now also notice though it returns back something called a time_t. Now previous to this demonstration we've done things like let's have an integer, say result, or let's have a character pointer. Oh, let me just call it env value, just as an example of how we use the character pointer. But now we're going to have something called a time_t. And I'll say, let's see, I'm going to call this, how about start time? So it turns out as you're running, you may want to take a timestamp, and this time function will return the current time. So we could say start time is equal to this. And so that will take a stamp, basically what time is it. Now we're going to see the way the time is represented is a little bit different from you looking at time, say on your phone or your computer. We'll see that it's represented a little bit differently. But let's say we get the start time, and let's say we go to sleep. Now this is something else we've not seen before. This is number of seconds. Let's say sleep for 1 second. Now, this is a function that we've not talked about before. And I want you to notice, as soon as I typed it, we see the green curly braces, which tells us, hey, something's not right. That's a warning. And in fact, we put it over here and it says implicit declaration of function sleep. Implicit declaration. So that tells us sleep is not in standard IO and it's not in time.h. Right? It must be in another header file. And of course, we could search the web and find out what that is, but instead of doing that, I want to try some things. I want to say, well, I remember we talked about standard lib.h. We certainly did that one. And notice, even though I typed in standard lib, we see that the sleep is still not declared. So it's not in standard lib, right? It wasn't in that one. And you could even say, well, gosh, is there something maybe, is there a include, maybe there's a sleep. It's not, but I'm just showing an example. In fact, we see here we have an error that is a absolute error here. So you could look up and find out where it's at. And what I want to show you is how to look these things up. You have several options. First, I want you to notice if I just ignore that right now and I click on run, Notice here it says implicit declaration for sleep is invalid in C99. Now sometimes it will actually show you where to pick that function up. But obviously it didn't do it here. It's just telling us that, hey, this is implicit. We know it's not in standard I/O. We just know it's not in time. But it's the best thing would be able to look this up. So I'm going to open up another browser window. I'm going to go to the Linux man pages project. Now, Linux man pages, man stands for manual. Notice 1, 2, 3, 4, 5, 6, 7, 8. In the old days, long time ago, there were actually separate volumes. These were separate books. So volume 1, volume 2, and so forth. The sleep happens to be inside what's called library functions in section 3 of the manual. Here's the manual page for the sleep function, which is what we're using. And notice it says this allows you to sleep for a number of seconds. Aha! The synopsis is what you as a software developer need to know right away, and we find the header file is unistd. Aha! Unistd. So now, and of course we see the function, it's called sleep. We pass into it the number of seconds we want to sleep. It will return to us, I think it returns to us how many seconds we're actually slept if you returned earlier. But what we'll do is say, so now we know include unistd.h. The uni comes from Unix. Unix was the operating system before Linux, and so that's where that comes from. Unistd means Unix standard. And notice as soon as I added this header file, sure enough, the sleep is now valid. So what I want to do is have a time type end time and say end time equals time of null. And this means I've got the start time and the end time, and of course we expect there'd be 1 second difference between those. Let's print these out. Let's do a printf, and we'll say start time is percent. Wow, percent what? This is time type. I mean, we've used decimal and we've used a string, but time type, I wonder what that is. And so we're going to introduce yet another new one, something called a long unsigned. And I'm going to say, put that long unsigned here for the start time. And let's also do a print. Well, I can just copy and paste. And let's say the end time long unsigned. Don't worry about the details too much right now, but basically it means it's an unsigned number. Turns out this is a signed number. The difference between a signed versus an unsigned is whether you have negative numbers or not. An unsigned number does not have negative numbers. And the L stands for long, which means it's a big box as opposed to a small box. Again, don't worry about the details too much right now. Just know that to print out time values, and look at me for getting my backslash in. Can you believe that? So the thing to remember is that time from the perspective of the computer is just some number. And in fact, we see the number here. You can tell it was this number ending in a 4-1. And then after 1 second, we see it ended in a 4-2, which tells you this big number that's keeping time, it incremented by 1 second. Later in the course, we'll go into more detail about what this time, where this number comes from. But for right now, just observe that sure enough, this number, whatever it is, it went from from a 1 to a 2 in this lowest position, which says, yep, we slept for that amount of time. Now, if you wanted to convert this into human readable time, probably the easiest way to do that is say, have a character pointer. Let's say the start, how about message? Or we'll call it the start string, so str. So we're defining a box called the start string, and we'll say assign the start string equal to, here's a new function for us, ctime. And when you have ctime, you pass in the time you want it to convert into a string. So in this case, start time. And so that means we could do a printf, I'll say start string %s, right, for a string, %s, start string, so we'll print that. And then last, we'll do the same thing again. Let's have a character pointer end string, and do the end string is equal to ctime. This time it will be the end time. And once again, printf, we'll say end string is %s. Now, oops, not end time, the end string. Now notice, anytime you get warnings, you want to look at that warning. And before we look at it in detail, if I click on run, notice we get the warnings here as well. And you can see it gets pretty scary when you see all this stuff. It's like, whoa, that's a lot of scary stuff. Not only that, when we ran our code, this is actually pretty cool. We had, for the first time in this course, we've had a hard crash. Our program actually crashed, and the reason it crashed, we have a segmentation fault. In other words, we accessed something that we should not have accessed. We actually accessed something we should not have accessed. And this is a great example of how if you choose to ignore these warnings, it may come back and bite you. And in fact, we've seen that here, segmentation fault. So come back here, and it tells us, it says incompatible integer to pointer conversion. Wow. So something's incompatible here. It says incompatible conversion, passing a time type, aka long. So we see that a time type is actually a long. Again, don't worry too much about the details. To parameter type, constant time type, pointer. Notice the star, pointer. Aha! This is super cool. We were trying to pass in the variable, the box. And it's saying, no, don't pass in the box. Pass in a pointer to the box. And the way we use the pointer is this syntax here. And I'll do that for both of them. This says, this is the name of the box, but remember your index finger, I want to point to where that box is at. I want to point to where that box is at. Not pass in the box itself, but rather pass in a pointer to that box. So let's click on run now. Whoa, check that out. We actually have it running where we see not only the computer time as a number, but we see it printed out in a time as well. So pretty cool. Now this time may or may not match your local time, because remember, you're running on a remote server, and the time zone of the server can can be different from your time zone. So don't worry if this does not match where you're at. Okay, well that was a that was a pretty intense one. You might want to watch this multiple times. In fact, all of these videos, the nice thing, you can watch them multiple times. But as a high level, we looked at the time.h. We saw there is a function called time where you can get the current time. We also saw there's a function called ctime, which will print out the time in human readable form using that as an input, a pointer to where the time is at. So thank you once again for making it this far. A lot more to come. We're just getting warmed up. I'm Norman McIntyre. Thanks as always for watching.